Today I'm gonna show another video on this coil shorting technique. The system is already running, save me some time and also hopefully make the video shorter. The system I have running on 18 volts at 650 milliamps, and I'm using all my 3 speeds. The RPM is now at, as you can see here, 1996. 1996. 18 volts at 650 milliamps. Sorry about that. 1996 RPM. System is now unloaded. The coil is open. As you can see on the below here, there you can see the small circuitry for coil shorting. It is using 2 N-channel MOSFET IRF 840. Those are the MOSFET mostly being used in switching mode inverters. I have here a capacitor, is not being used yet, and I'm gonna put a 5-watt load on it. These 5 light bulbs, each one of them is 1 watt. I'm gonna put now the load, which is the coil, on the system without the coil shorting. So here goes the load, the coil itself. Then we're gonna check the output of the coil, measure the RPM, and see what the input is doing. It should be, and it is so, and it is putting a drag on the system. At this moment the output is 9.6 at, yeah, let's say 80 milliamps, and the light is, yeah, not bad at all. Let's check the RPM. RPM is now 1882, 81, 80. Let's give it some more time. So it has dropped already around 110, 115 RPM. And the input went from 18 to 18.2. And it went from 650 milliamps to, let's say, 675 milliamps. No, it went from 650 milliamps to 725 milliamps. Yep, that's better. 725 milliamps. So that's about 75 milliamps more, and 0.3 volts more. Let's check the RPM again. RPM is now 18, 68, 69, 1868. RPM is 1868 with the coil loaded, without coil shorting, and the output is 9.5 at, yeah, let's say 70 milliamps. Output is 9.5, 70 milliamps. Now I'm gonna connect this lead over here, because I am running the MOSFET and Hall on that small 9-volt battery. And now I'm gonna start the coil shorting. Gonna put it over here so you can see the voltage climb and also see the lights get brighter when I do that. Here it goes. And I can clearly hear the system slowing down a lot. As you can see, voltage is now 18.5. Milliamp is almost 800. voltage is dropping because the system speed is also dropping, and the milliamps output is now 100. One thing about this MOSFET Hall system, that the output, the switching is very clean and very stable. Let's check the RPM again. RPM is now 7310 and decreasing still a little bit. Let's give it some more time. So in my case, shorting the coil out does give me a little bit more of the output, but also more drag on the system. Here once more the tiny circuitry for coil shorting. The Hall sensor is behind there, running on a 9V battery. Input is now 18.7 or 6. It is pulsing around 800 milliamps, 800 to 850. Output is now pretty stable at 9.9 and 100 milliamps. And the RPM is 1700 precisely. Yeah, it's pretty stable around 1700. Yes. So we're gonna write in here 1700 RPM, coil loaded including coil shorting, and the output is 9.9 at 100 milliamps. So the total decrease in output is the total is 96 RPM. That is coil shorting and also coil loading. And the output, yeah, output went from 9.5 at 70 milliamps, which is 0.665 watt. That was the coil loaded without shorting, and with shorting is 9.9 times is 0.99 watt. So the output went from, let's say, 0.6 to 0.9. That's about 30% more, and the RPM went over there is 128. The coil only makes the system drop with 128 RPM. The coil including shorting makes the system drop almost 300 RPM. So that's more than double, while the output is only 30% more. So I don't see any gain there. Once again, the input, and the input went from 18 volts at 650 milliamps to 18.6 to, yeah, let's say it's pulsing between 800 and 850, let's say 825. Nope, I don't see any gain here. You gain something, but you lose more. But like I said, this system does switch very clean and very stable, and that's a good thing. There's a light in the dark. Yeah, the pulse motor is pretty good light up. So yeah, don't worry about that little lamp over here. That's a Joule thief test running, but that's another story. What I'm going to do next is, I did now the basic coil shorting, which is this schematic over here. Then I'm going to start using the capacitor in series, in parallel, and also going to start shorting the coil a different way, shorten it through the load, and see how that goes with the coil in series and in parallel. Now hopefully I said anything that need to be said. Hope you enjoyed it, and thanks for watching.